So the session is being recorded right now. And this question, the first question we did, guys, before, and this is not a normal curve because the curve crosses the x-axis. A normal curve does not cross the x-axis. It barely, just touches the x-axis. So you choose that this is not a normal curve because it crosses the x-axis. Okay. Next question. So we selected, could not represent a normal curve right here. Okay, this area, as I said, you could have used the table that pops up, or you could use simply normal CDF in here. And if you use normal CDF, it will be normal CDF. Lower bound, the lower bound will be 0.56. Upper bound will be right here, which is you can use 1,000,000. And since this is a Z, so you have to put 0 and 1. And how do you find, this formula again? Let me show you. You go to second, distribute, normal CDF, and put 0.56. Enter 1,000,000, it's already there. Your mean is 0, and your standard deviation is 1. And hit paste, and the answer is 0.287. You just enter it right here. How many decimals? He said 4 decimal places, so it will be 77. All right, so let's go to the next one. Area between two z-scores -1.1 and 1. So you just can do it right here. Second, variables, normal CDF. There is a -1.1. Make sure to use the proper negative sign. And upper is 1, and then 0, 1. So it's very easy when he gives you area between two numbers. So, and that will be what? 0.7057. Remember, I'm rounding to the 4th decimal place.
Mr. Bazzi, I think your screen froze.
Does everybody have this issue? Next question. Find the probability. If he asks you to find the area, guys, or find the probability, it is the same thing. So the reason why I put this question there, it says a probability. It's the same thing as the area. Area between 0 and 2.6. So you just do it right here. Second, distribute, normal CDF. So you're going to make good use, just of the normal CDF function here. 2.16. and 0, 1. Okay, enter. So you get 0.4846. And then check answer and then move on. What's the probability of Z less than -0.61? Okay,
Mr.
less than
Bazzi?
0.61.
The screen is frozen.
All right. So annotate, and let me get the pen one more time. Okay, so we need less than, so this is 0 right there. This is Z. less than negative 0.61. Negative 0.61 will be here, guys, and less will be this area. Okay, so you got the upper bound, you need the lower bound, which is negative 1 million. Well, let's make it easy. If it is a less than, the lower bound is always a negative 1 million. And then the upper bound would be negative 0.61. So to do this, we're just gonna go to the other side, second, variables, normal CDF, enter, okay. Negative 1 million or 1 billion, just put as many zeros as you want. Negative 0.61 and 0 and 1. Now, guys, if you don't see the window that I got previously, you're going to get normal CDF parentheses on your calculator. So you input the lower bound, you put a comma, you put the upper bound, you put a comma, you put 0, comma, 1, and then close it, and you should get the answer. And the answer here is 0.2709. So you just simply input this answer. All right, next. Okay, we'll clear. Probability of Z greater than negative 2.04. So it's going to be negative greater than. So the lower bound is going to be negative 2.04. The upper bound is million. So you just put negative 2.04. Upper bound is 1 million and 0 and 1. There you go. It's 0.9793. If you like, guys, as I do this, if you want to just check the answers with me, that would be great. Now he wants a probability of X between 64 and 73. So the mean is not 0 and the standard deviation is not 1. He's going to give you the mean and the standard deviation. So you just go to second, distribute normal CDF, 64, 73. Mean is 80. So it's not 0 and 1, guys, and sigma is 5. You gotta use that. And you get 0.0801 if it is 4 decimal place. And let's move on. In a recent study on old happiness, participants were asked to evaluate their current lives on a scale from 0 to 10, where 0 represents the worst possible life and 10 represents the best possible life. The responses were normally distributed with a mean of 5.1 and standard deviation of 1.8. What's the probability a randomly selected study participant response was less than 4? Less than 4, we need, so less than 4, the lower bound is going to be negative 1 million, upper bound is 4, and the mean is given 5.1 and standard deviation 1.8. So let's do it. So negative 1 million. Less than 4, that's a 4 here. And the mean is 5.1. And the standard deviation is 1.8. So you get 0.27. You just enter it and make sure to check the requirements. He said 4 decimal places, so it will be 0.6. Find the probability a randomly selected participant response was between 4 and 6. Between 4 and 6, guys, that should be lower bound is 4 and upper bound is 6. So here's the 4. Here's the 6, and leave the 5.1, 1.8 alone. Okay, so you get 0.4209. What's the probability randomly selected study participant response was more than 8? More than 8, so 8 is the lower bound and the upper bound is 1,000,000. Trying to put the responses, so if you guys review it, you can see the responses while you do the questions. So upper is 1,000,000 or 1,000,000,000. And that doesn't change at all here. So you get 0.0536. Identify any unusual events. An event is unusual if it is less than 5%. As you notice, none of those guys is less than 5%, so you have to choose the one that says that. Are not, and so not unusual. There are no unusual events because all the probabilities are greater than 5%. Okay, here is another one. Find in a recent year the scores of the reading portion of a test were normally distributed with a mean of 22.2 and a standard deviation of 6.1. Complete parts A through D. Find the probability that a randomly selected high school student who took the reading portion of the test has a score that is less than 19. So less than 19, you already know what to do. It's going to be negative 1,000,000. If it is a less, your lower bound is always the -1, and this is the 19. And then we're going to put the mean, which is what, 22.2. As you can see, this question shows up twice, so that must be an important question, guys. So you might see something similar to it. So it will be 0.2999. Find the probability randomly selected high school students has a score between 16.2 and 28.2. So this is 16.2. The in-between is always easy. You don't have to think of lower and upper. They're already given to you. 28.2. And then leave the rest alone. And it's 0.6747. And what's the probability that randomly selected high school students has a score of more than 34.8? More than 34.8, so 34.8 is the lower. The upper is 1,000,000. And leave the rest alone. 0.019. Identify any unusual events. Do you guys agree with me that there are unusual events in this one? It's in C because it's less than 5%. So the event in part C is unusual because the probability is less than 5%. And then we move on. Find the Z-score that has 49.2% of the distribution area to its left. Let me sketch this one and show you how to. When you find the Z-score, it's an inverse norm. So it's going to be this. He says the area is 49.2%. Okay, this is the area to the left. This is 49.2%. And he wants that Z-score. Well, you guys, you know, it's inverse norm, area to the left, which is 0.492. And since this is a Z, 0 and 1. So let me just do this. Second, distribute again, and it's inverse norm. Area, 0.492, enter, 0, 1, left. You might not have the tail. If you don't have the tail, don't worry about it. Just do the area to the left. It's going to work. By default, it's going to be on the left always. And the Z-score is negative 0.02. As you notice, it's very close to the center. Yeah, so that answer makes sense. All right. The test score for the analytical writing section of particular standardized test can be approximated by a normal distribution. What's the maximum score that be in the bottom 15%? Okay. Maximum score that can be in the bottom 15%. It's gonna be this. This is the bottom 15%. And he wants the X value here, not Z. He didn't say, he gave you a mean and a standard deviation. Look, score. He didn't say what's the Z score. So we need X. It's gonna be inverse norm. Area on the left is 0.15. But you don't put 0 and 1 because he's giving you a mean and a standard deviation. So it's an X value. Just put 3.3 and 0.87 because you can look at the graph. He gave you the mean and the standard deviation. So let's go here, second, and distribute. Inverse norm. So area is 0.15. Enter the mean, which is 3.3. Standard deviation 0.87. And again, you can ignore this part if it doesn't show on your calculator. And it's 2.3. How many digits? He says around to 2 decimal places. So it will be 2.3, will be 2.40. The middle 70% now. Let me show you about this. How do you do the middle 70%? Middle 70%, usually 2 values. So put 70% in the middle. He wants this value and that value. Well, if you put 70% in the middle, what's left from the 100% total area? 30%. Split them up. Here goes 15%, and over there goes another 15%. Okay, to find X1, guys, to find X1, you need inverse norm of 15%, which we already did. And then the mean, which is 3.3, 0.87. Now, what about X2, guys? Can someone tell me how to find X2?
Would it be 85?
85, exactly, because you have 70 and 15. 3.3, 0.87. Okay, since we did the first one, guys, so I'm not gonna do it again, but we're just gonna go and do the second one. Second, distribute. Inverse norm 0.85. You can see the 0.15 still shows on the screen. So your answer will be 2.40 and 4.20.
To find x2, are you always going to have to add, or will ever be given?
What is it for x2? Look, this is, I'm gonna give you a shortcut to do it. If you see a question on the final exam, it says middle 80%. Let me tell you what you do. You take the 80% subtracted from 100, you get 20%. Divided by 2, you get 10%. So the first value you do it inverse norm 10%, comma mean, comma standard deviation. The second one you do it inverse norm, not 10%, subtract the 10% from 100 will be 90%. 90%, comma mean, comma standard deviation. Look here, we did 15. We did 15 right here. And the other one will be 100% minus 15, which is 85%. You can see the 85% here. Same question on the inverse norm. The red blood cell counts for a population of adult males can be approximated by a normal distribution. Mean is 5.9 and standard deviation is 0.4. What's the minimum red blood cell count that can be in the top 30%? Top 30%, so your 30%, guys, is right here. So we can tell me how we're going to find the X value. It's going to be inverse norm, what? Area to the left. What's the area to the left?
70%.
70.
Yeah. Most calculators are programmed to accept only area to the left first. Unlike mine, you can do it in all ways, but I'm not going to assume that you have this one. So, and probably you do because that's what I asked you to download anyway. So 0.70, 5.9, 0.4. So let's go and do this. As you can see, I'm not using an actual calculator. I'm using the simulator. 5.9 and 0.4. Okay, I got 6.1. How many digits? It says 2, so it would be 6.11. What's the maximum red blood cell count that is can be in the bottom 11%? Well, bottom 11%, guys, watch right here. Let me change the color. So what is it gonna be? Inverse norm. You guys agree it's 0.11 mean and standard deviation. So you just go there. So will be 0.11 and nothing else to change here. 5.41. Okay, let's move on. Clear. A population has a mean of 78 and a standard deviation of 23. Find the mean and the standard deviation of the sample means. When we work with samples, the mean of the distribution will be the same as the original population mean, but the standard deviation will be the original standard deviation divided by the square root of the sample size. So your mean here, guys, it's going to be 78. This is called the central limit theorem. And your standard deviation, it's going to be 23 divided by square root of 257. I'm just going to write it down so you know what to do here. So you compute square root of 257 on your calculator, just like this. Let me show you on a clear. So it will be 23 divided by, and the square root is right there, 257. So how many digits? He says 3 decimal places. So if you just want to put the answer, it will be 1.435. That would be the answer. The population mean and standard deviation are given below. Find the required probability. And determine whether the given sample mean would be considered unusual or not. For a sample of 62, find the probability that sample mean being less than 24. Remember here, the question is about the sample mean. So he wants a probability of X bar less than 24. Let me show you how you do it. Same thing as we did previously. So we just use normal CDF. Lower bound, it is less, -1 million. Upper bound is 24. Mean is given to be 24. But just be careful here. The standard deviation is not 1.3. When you work with the sample means, the standard deviation should be 1.3 divided by square root of the sample size. And what is the sample size here is 62. So that's the difference. The difference is right here. Okay, so how do you do this? Normal CDF. Okay, negative a million. Doesn't matter, you can put as many zeros as you want, 24. And the mean is 24 as well. But the standard deviation, guys, is 1.3 divided by, and you can do it here, square root of, what's the sample size again? 62. Close parentheses. And I got 0.500, so would the given sample mean be considered unusual? Well, I didn't get less than 5%. Would not, because the probability is greater than 5%. It's only unusual if the probability is less than 5%. Okay, let's clear here. Use the central theorem to find the mean and the standard error of the mean. Standard error of the mean is the standard deviation of the sample means, which is sigma over square root of n. Then sketch the graph. The mean price, okay, we know that the mean is the same as the mean, so it's going to be 231. That doesn't change. The standard deviation, it's going to be 69, but divided by square root of 29. So what is 69 divided by square root of 29? I got 12 point, how many digits? He said 3 decimal places, 813. And now, guys, you have to find the graph that has a mean of 231 and extends 3 standard deviation of 12.8. 12.8 is about 13. So 231, and if you add 13 3 times, it should take you to what? About 270. And it seems to me like this one will do it right here. So let's see. Okay, the mean percent of childhood asthma prevalence in 43 cities is 2.16%. A random sample of 33 of these cities is selected. What's the probability that the mean childhood asthma prevalence for the sample is greater than 2.6%? Assume that sigma is 1.35. Okay, so this is about what's the probability that the mean, so it's a probability about the sample. We need probability of X bar being greater than 2.6. So let me show you how to do that by hand first. It will be normal CDF. 2.6% is the lower bound. The upper bound is, just 1 second. You can go to 100% or a million. So I can put a million, so not to confuse. And I'm not gonna use the percentages, so I'll just eliminate all the percentages. Put 2.6, a million. And then the mean is what? 2.16. You can see the mean right here. The standard deviation, he says 1.35, but it's not 1.35 in our case because we're working with sample mean divided by square root of the sample size, which is 33. So if we go to our calculator, watch. Okay, lower is 2.6. Upper is a million. Mean is 2.16. And standard deviation is 1.35 divided by square root of 33. Okay, I got 0.0306. How many digits? He says 4. And now interpret this probabilities. Well, it's not samples of 43, it's samples of 33. Greater than 2.6. It's going to be right here about, okay, can you change this one to a percent? It will be 3.06%. Of samples, it will have a mean childhood asthma prevalence greater than 2.6%. Okay, clear. Okay, this is probably the last question from the chapter on probabilities. The mean height of women in a country age is 63.9 inches. A random sample of 60 women in the age group is selected. What's the probability that the mean height of the sample is greater than 64? Again, guys, I put a lot of questions from this chapter just to refresh your memory and show you that it is an important chapter. So you're going to have quite a bit from this. Normal CDF, okay, greater than 64. 64 is a lower bound, upper bound is 1,000,000. Mean is, what did he say the mean is? 63.9. And just be careful with the standard deviation. It's not 2.74, it's 2.74 divided by the sample size, square root of 60. And go in there, clear. Second, distribute. Normal CDF. I got 64 million. 63.9. And finally, 2.74 divided by square root of 60. There you go. So we get 0.3887. All right. You construct a 95% confidence interval for a population mean using a random sample. The confidence interval is mean between 2.4, 24.9 and 31.5. Is the probability that the mean is in the interval is 0.5? No, it means with 90% confidence that the mean is in the interval 24.9, 31.5. The interpretation of the confidence interval, guys, with 90%, 5% confidence, we can say that the true mean is between those two values. It doesn't mean that the probability is 95%. Use the confidence interval to find the margin of error and the sample mean. Do you guys still remember how to find the margin of error if you have the interval? What do we do?
Do we subtract the
Yes, subtract them and do what?
Divide by 2?
Exactly. And then divide by 2. So 0.16. And how do you find the mean, sample mean? Add them and divide by what? By 2. .74, 73. All right. Use the confidence interval to find the estimated margin of error. Same question, subtract and divide by 2. So this is going to be 4.1 minus 3.5. When I repeat a question, guys should know that probably it's an important question. So 0.3. And the sample mean, you just add them So it's going to be 3.5 plus 4.1, 7.6, and that will be 3.8. Next. You are given the sample mean and the population standard deviation. Use this information to construct 90%, 95% confidence interval for the population mean. A random sample of 55 home theater system has a mean price of 113. Assume the population standard deviation sigma. So guys, here's the deal here. From now on, if he gives me sigma, it's a Z distribution. If he doesn't give you sigma, it's a T distribution. And here he did give me sigma. This is sigma. So we're going to go to a Z interval. So stat, tests, Z interval. Summary. Okay, sigma, you see, that's the first prompt. We have to find what sigma, put sigma 19.8. X bar is 113. N, what did he say? N, a random sample of 55. And let's do the 90% first. So 2 decimal places, 108.61. Actually, the calculator by default does 2 decimals. And 117.39. Now he wants the 95%, so just go back. Okay. Just change this one to 95. Oops, what did I do? Go back. Don't do one step, an additional step. You will lose the interval. There you go. So 107.77. It's already rounded for you guys. Just copy it as is. Okay, interpret the results. With 90% confidence, it can be said that the sample, not the sample mean, this is about the population mean. We already know the sample mean. So with 95%, it can be said the population lies in the first interval. With it can be said, yeah, that, and the 95% interval is always wider. As you increase the confidence level, your interval becomes bigger and bigger. So that's. Find the critical value TC for the confidence level C equals 0.99 and sample is 11. So if I show you the table, guys, the critical value, you need degrees of freedom, which is 10 here, and confidence level 0.99. Here you go. This is the 0.99, and this is the 10. It will be 3.169. Next. In a random sample of 22 people, the mean commute time to work was 30.6 minutes, and the standard deviation was 7.3. He didn't say population standard deviation, so this is S, guys. Assume that the population is normally distributed and use T distribution. You see, now he's telling even you what to do. Use T distribution to construct a 95% confidence interval. So here it is, number 8, T interval, X bar, 30.6, S, 7.3, N is 22. And the reason why he told you that the population is normally distributed because the sample size is less than 30. If a sample size is less than 30, in order to perform Z or T, you need to you need the population to be bell-shaped. And what does he want? 95. There you go. So you get 1 decimal place, 27.3. Oops, what happened here? Let's go back. I don't remember what was the results. Okay, so 27.4 actually, not 0.3, and 33.8. What is the margin of error? If you guys have the interval, the margin of error, subtract the 2 and subtract lower from upper and divide by 2. So it will be 33.8 minus 27.4, which is what? 6.4, and divided by 2, it will be 3.2. So it's easy. Once you have the interval, you can find the margin of error. Okay, that's it. With 95% confidence, it can be said that the population mean commute time is between the bounds. He doesn't list them, but it's okay. It's just between the bounds and the interval. In a random sample of 4 mobile devices, so N is 4. The mean repair cost is $65. And the standard deviation S. If he doesn't say population standard deviation, guys, just don't put sigma, it's S. Assume that the population is normally distributed. Find a 99% confidence interval and the margin of error. Okay, it's the same thing as I did here. So I'm just gonna take you back and do the same thing. And I wanna do them because it's been a while since we did confidence intervals, so it would be a good refresher for you. 65. S is 13.5. N is 4. And confidence level is 99. This is the highest confidence level that we work with. So we get 25, how many decimals? 2 decimals, 25.57 and 104.43. Margin of error, guys, you just subtract 104.43 minus 25.57, get the answer first, and then divide by 2. 39.43. Interpret the result. Okay, with 99, it can be said that the population mean repair cost is between the bounds of the interval. All right, clear. Let be the population proportion for the following condition. Find the point estimates for P and Q. The estimate of the proportion is P hat, which is X over N. So you write it down. He gives you X to be 192. This is X, and the sample size is N. So it will be 192 divided by 1205. This is the sample proportion. That's what he wants. So a point estimate for the population proportion is the sample proportion. 192 divided by 1205, guys. 0. How many digits? 3 decimal places. So 0.159. Does anyone know what the estimate for Q would be, which is probability of failure, not success?
1 minus.
Exactly, 1 minus. But you compute the answer, guys. Don't leave it like that. The system will mark it wrong. But I'm just showing you it's 1 minus 0.159. All right, let's clear. In a survey of 2018 adults in a recent year, 1250 said that they have made a New Year's resolution. Construct a 90 and 95% interval. It's a very important question, guys, and very easy to do if you know what you're doing. It's a proportion interval, not Z interval. It's a proportion right here, A. Okay, he wants X. X is always the smaller number, so 1250. Then he wants N, which is the larger one, which is 2108. Confidence level, let's start with 90. There you go. Round to 3 decimal places, so 0.575. And 0.611. 95% confidence. Oh, sorry. Stat. Okay, same thing, guys. Just do this, 95. Okay. It's going to be a wider interval, 0.572. Can see. The lower will become lower and the upper will become higher, 0.614. Okay. With the given confidence, it can be said population proportion, never about the sample proportion. We already have the sample proportion is between the endpoints, always between the endpoints. The 95% interval is always wider. A researcher wishes to estimate with 99% confidence the population proportion of adults who think Congress is doing a good or excellent job. Her estimate must be accurate within 5% of the true population. Okay, how do you estimate the sample size N? Here's the formula. You will be provided with the formula if you need to use a formula that's not built on your calculator. That's the formula. Okay, if no preliminary estimate is given, guys, as I told you before, your P hat and Q hat, you have to use 0.5 each. Okay. Now we need to find Z. What is the confidence interval? He says 99% confidence. Does anyone know what the Z value by heart is? Okay. No preliminary, find the minimum. Okay. Excellent. Her estimate must be accurate within 5%. The within 5% is the margin of error. So E is 0.05. Does anyone know what the critical value here is at 99%?
2.575.
2.575, exactly. But let me show you, if you forget how to do this, look what you do, guys. You do it with any confidence level. Take 100% and subtract it from the 99%, which is this, will be 1%. Divided by 2, change it to a decimal. Divided by 2, it would be 0.005. And now go to inverse norm and put 0.005, comma 0, comma 1. You should get the 2.575 that you just mentioned. Let me show you that it does work. I'll be in trouble if it doesn't work. 0.005. It wasn't going to work with 2. There you go, 2.75. The book says 2.75. You can use 2.576. There is a negative, ignore the negative sign. Even if you don't ignore it, you're gonna square it, so it's gonna be positive. So I'll go back here and square it. And let's see what the answer is on the calculator. You need to use the calculator. So do 2.575 divided by 0.05 equal, square it. That is how you square it. Just go here, hat and 2. Then multiply by 0.5 and then multiply again by 0.5. You can do it in steps, guys, if you want. Remember, the sample size cannot be a decimal, and you always have to round up when it comes to sample size. So it should be 664. Always round up. Okay, let me clear the drawings. What's the minimum sample size needed using a prior study that found that 32% of the respondents said that they think Congress is doing a good job? Now he gives you an estimate of p hat. All right, so it's going to be the same formula. Watch. Now your p hat is 0.32. It's not 0.5, 0.5. Your q hat is always 1 minus. And same thing, 2.575 divided by 0.05 squared. Okay, let's do it on the calculator. 0.32 times. If you don't want to do the math, just do this 1 minus 0.32 first times. Open parentheses, I'm going to do it all in one shot. Divide by, and then square it. You can use this for square. 577.12, you need to round up, so it will be 5.78. 578, sorry. If it's always when you have an estimate, you need a smaller sample size. So reduces, that's it, it's B. Having an estimate reduces the sample size. Clear? Okay. Use the given statement to represent a claim, write the complement. Okay, so mean is less than or equal to 665. You guys agree with me that the complement will be mean is greater than 665. And the claim here happened to be in the null hypothesis. So find the complement, it will be greater than, and let's select them. Which ones? Oh, there you go, right here. Okay, so that's an easy question. Okay, write the statement. Standard deviation of the base price of a certain type of all-terrain vehicle is equal to 307. So equal, it will be right here. What's the alternative, guys? You guys agree with me? It will be not equal to, so it will be this. Identify which one is the claim. Well, since it's an equal, it's on the null hypothesis, so it will be the null hypothesis right here. Describe type 1 and type 2 errors for a hypothesis test. Type 1 error is when you reject the null hypothesis when it is actually true. So you're rejecting something that is true. That's a mistake. And type 2 error is when you fail to reject the null hypothesis when it is false. So a lumber store claims that no more than 25% of its new customers will return to buy their next order of lumber. No more means what? Do you guys agree? No more means less than. Oh, sorry, proportion here. So P is less than or equal to 25%. Okay, what is a type 1 error in here? Describe a type 1 error. So a type 1 error when we reject HO, so actually the percentage of people who will buy lumber again is no more than 25%, but we end up rejecting this. So we'll just look for this language. Here you go. A type 1 error will occur when the actual proportion of new customers who return to buy their next order in lumber is no more than 25%, but you reject this. Type 2. Let's read which one. Type 2, you fail to reject HO when it is actually false. So actually the proportion of customers who return to buy is not no more than 25%. Actually, it's more than 25%. So a type 1 or 2 error will occur when the actual proportion of new customer to buy their next is less, though that's not true because no more means less as well. Type 2 error will occur. Yes, right here, B. All right. Determine whether the claims stated below represent the null hypothesis or the alternative hypothesis. If a hypothesis test is performed, how should you interpret a decision that rejects the null hypothesis or fail to reject the null hypothesis? Okay, a scientist claimed that the mean incubation period for the eggs for a species of bird is more than 45 days. Okay, guys, you agree that the claim is in HA or H1? That's HA. And if you want to write HO, it will be this. Okay. Does the claim represent the null or the alternative hypothesis? Since the claim does not contain a statement of equality, so if the claim doesn't have equal, less than or equal, greater than or equal, it is in the alternative hypothesis. How should you interpret the decision if you reject the null hypothesis? If you guys reject the null hypothesis, what do you say about the claim? Can someone tell me? Yes?
There. What?
There is
Oh,
Sufficient
sufficient evidence
it's
to?
sufficient. Oh,
support.
Yep. If the claim is in HA and you reject HO, you support the claim. How should you interpret a decision that failed to reject the null hypothesis? So just change sufficient to what? Not sufficient evidence. You don't use the word reject when the claim is in HA. No, it's always the word support. Okay. Clear? The p-value for the hypothesis test is shown. Use the p-value to decide whether to reject HO or not. Okay. If the p-value is 0.0367 and alpha is 0.01, would you reject HO? Well, let's see. It's just 3 questions in one, guys. It's bigger than alpha. So we fail to reject HO. What about if alpha was 0.05? Well, guys, if alpha is 0.05, that's going to change the story. That's less than 0.05. So we reject HO. So it all depends on alpha. And if alpha is 10%, well, definitely you're going to reject HO because 10% is bigger than 5%. All right. Find the p-value for the indicated hypothesis test with the given standardized test statistic. Decide whether to reject HO or for the given level of significance alpha. Okay, let me clear this. Okay, the p-value here, since this is a right tail test, this is not a complete hypothesis testing question, guys. So Z is 1.25. And as I explained to you, the p-value is an area to the left or to the right or in between. Since he says it's a right tail test, so the p-value is the area to the right of 1.25. And to find this area, you need to do normal CDF. 1.25, a million, sky is the limit, 0.1. Let's see what the calculator gives us here. So 1.25, upper is a million. and 0, 1. Watch, guys. Oops, what happened? Let's do it again. I put two commas or 2 decimal points. Okay, I got 0.066 or 0.067. All right. Do we reject HO or fail to reject HO? Well, the p-value is bigger than 4%. Alpha is 0.05, so we fail to reject HO. All right. Now we're going to do a complete hypothesis testing problem. A random sample of 76 eighth graders. So N is 76. On students score on a national mathematics assessment test has a mean score of 264, so X bar. This test result prompts the state school administration to declare that the mean score for the test 80th grader on this exam is more than 260. They make a claim that it is more than 260. Assume that the population standard deviation sigma. You see, guys, he says sigma. At alpha equal 5%, is there enough evidence to support the claim? Okay, let's do the 5 steps now. Well, more than, so we need the more than, where's the more than? Right here. But the claim, no, it's not here, so it's gonna be this. The claim is more than, so that's where the null in the alternative. Okay, it's a z-test. I'm back. So z-test. Okay, we're testing against 260. Sigma, you see, he's saying sigma here, not S, 39. X bar, 264. N is 76. And we need the alternative is greater than. And here we go, calculate. So Z is 0.89. P-value is 0.1856. Fail to reject HO, it's bigger than alpha. Interpret the decision. There is not enough evidence to support the claim. Clear. Use a t-test. You see, he's telling you what test to use here. To test the claim about the population mean mu at the given level of significance alpha. Assume the population is normally distributed. So the claim mean is greater than or equal to 8,300. So which one are gonna pick? This one. What's the value? Okay, let's run the test, guys. T-test. 8,300. X bar is 8,100. S, you see, it's an S. Don't use a Z here. When it is S, it's always a T. Cannot emphasize enough on this. And N is what, 20? And what's the alternative hypothesis less than? This one, we put always the alternative hypothesis, not the claim. Okay, so T is negative 1.9. How many digits? He says 2 decimal places. P-value 0.036. Okay, do we reject the null hypothesis? So alpha is 0.05. Well, this p-value is less than alpha, so we reject it. So we reject the null hypothesis, and the claim is in the null hypothesis. So we say there is enough evidence to reject the claim. Okay, the next one. Unemployment Information Services claim that the mean annual salary for senior level production engineers is $96,000. The annual salaries in dollars for a random sample of 16 seniors are shown in the table. At alpha equal 5%, test the claim that the mean salary is 96,000. So it's mean equal 96,000. And here, same thing, mean, you have to pick the variable, not equal 96,000. And you guys agree with me that the claim is in the null hypothesis. Okay, use technology. Oh, here he's asking for critical values. Let me show you. You could have done this, guys, using static crunch. I'll show you. I'm going to show you that you don't have to input the data. So just watch me taking you to static crunch. So click here, open in static crunch. I would do it. And then go to data, stat. It's a t-test. We're doing a t-test here. One sample with data. And that's the sample right here. And we're testing against the value 96,000. Mean is not equal to 96,000, and that's all. And just hit compute. And look, guys, you're going to get the test statistic, which is negative 1.244, and the p-value. So you just go back and put them in there. I won't be asking any questions on the critical value approach, so it will be always p-value. I don't know how this got in there, but you get the results, guys. See how easy it is. But you could always enter them into your calculator. If you do your calculator, this is what you have to do. You go to stat, edit, you put your data in L1 first, and then after that you go to stat, tests, t-test, go to data, and put the 96,000 here. Select your data. Is it in L1? Make sure to select L1 and not equal. We're doing equal and not equal, and then hit calculate. Well, I'm not gonna hit calculate because I didn't put the data in there. So it's easier to use a static crunch here. Negative 1.244 and the p-value is 0.233. So test statistic is negative 1.244. And p-value is more than alpha. We fail to reject the null hypothesis. So fail to reject the null hypothesis. And interpret the decision. There is not enough evidence at whatever the level of significance is, the 5% level of significance to reject the claim is equal to 96,000. So he wants you to write the claim, just the way we usually write it. All right. A humane society claims that less than 73% of households in a certain country own a pet. In a random sample of 600 households in that country, 420 said that they own a pet. Is there enough evidence to support the society claim? So let's see which one is going to be. So you guys agree with me that P, that's what they're claiming. P is less than 0.73. So that should be an HA because it has a less than. So HO will be what? P is greater than or equal to 0.73. And this is where the claim is. Okay. Let's see. Identify the claim. Okay, the less than 73% right here. Put the 73%. Okay. And now state the null and the alternative hypothesis. Just copy what we put in there. So right here, 0.73 and 0.73. If they put a percent next to it, sorry, if they put a percent, so put 73%, but here they didn't, so just put the decimals. And what is this gonna be called, guys? A proportion z-test. If you remember that from chapter 7. Oops, stat tests. One prob z-test right here. You need the null hypothesis, 0.73, and you need x and n. Okay, x is 420, the smaller value always, and n is 600. And we'll test what's the alternative less than. Oops, if I go too fast. Calculate. All right, let's input some values there. Z, negative 1.66. P-value, 0.0489. And what is alpha here? 0.01. Well, this is bigger than alpha, so we fail to reject the null hypothesis. There is not enough evidence to support the claim. Well, he's asking you if you can support the claim, so you use the word support. Okay. Test whether mu1 less than mu2 at alpha equals 0.05 level of significance for the sample data shown in the accompanying table. So here's the table, guys. Do you notice he put S here? Once he put S, then it is a t-test, 2-sample t-test. Now we're talking 2 samples, so we're in chapter 8. Okay, determine the null and the alternative hypothesis. So mu1 is less than mu2. Where do I find this one? In C. Okay, let's run the test. Data, not data, I don't have a summary of the data. So X1 bar, population 1, X1 bar is 103.5. S1, 12.2. N1, 33. X2 bar, 114.2. S2 is 13.2. N2 is 25. And what's the alternative hypothesis less than? Enter. Okay, pooled. If he didn't say anything, it's always a no, but I'll make sure to say that on the test. But by default, in some books, if he doesn't say anything, you just select no. So it's still yes, enter. So if I say assume that population variances are not equal, you say you use no. And if I say assume population variances are equal, you choose pooled yes. But as I told you, I selected this question from a book that doesn't specify. When they don't specify, by default, we use a no. Okay, that's all I need. So what's the p-value here, guys? 0.001. Well, this is less than alpha. We reject HO, and we support the claim. There you go. There is sufficient evidence to conclude that mu1 is less than mu2. Next. Okay. Listed in the data table are amounts of strontium 90 milligrams or MBQ per gram of calcium in a simple random sample of baby teeth obtained from residents in 2 cities. Assume that the 2 samples are independent, simple random samples selected from normally distributed population. Do not assume that the population standard deviation are equal. So what does that mean, guys? When he says, do not assume population standard deviations are equal. Pooled is what? No. Use a 10% level of significance to test the claim that the mean amount of strontium-90 from city 1 is greater than the mean amount in city 2. So let's see. It's going to be this, greater than mu1 is greater than. And I'm going to show you how to use static crunch to do this. If you don't use static crunch, look what you do, guys. You put city 1 data in L1, you put city 2 data in L2, and you run a 2-sample t-test. So you go to stat, first of all, you go to stat, edit, put the data in L1 and L2. Then you go to stat, tests, 2-sample t-tests. You select data, because is your data in L1 and L2, you just keep it. What is the alternative hypothesis? Greater than. Pooled. He says, do not assume that the population standard deviation are equal. You select no and hit calculate, you get the answers. But for the sake of time, I'm going to do it using static crunch. You go to stat, t-stat, not 1 sample, it's 2 sample with data. I have the data. Column 1, city 1. Column 2, city 2. Okay. We're not pooling the variances. It's a no. If it is a no, you just don't select this one. See, by default, it's set to off, so no. So that's how it is. Okay. We're testing if mu1 is bigger than mu2. This one. Don't touch this one. And the mu1 minus mu2 equals 0, guys, means mu1 equals mu2. As I told you, some books don't put the equal, less than, or equal, greater than, or equal. They summarize it with an equal sign. So you don't touch this one. Just change this one to greater than. And compute. And here you go. Test statistic is 1.647 and p-value 0.0589. And you just input the values. What was it? 1.647. And the p-value was 0.0589. And what's alpha here? 10%. This is less than 10%, so we reject the null hypothesis. And we reject, so it's going to be B or C. And the claim is greater than, so we're going to support the claim. So which one has, yeah, this one. There is sufficient evidence to support the claim. Okay, please pay attention to this question, guys. This is from the section 8.3 dependent samples. The 2 samples are dependent. A food manufacturer claims that eating its new cereal as a part of a daily diet lowers total blood cholesterol. The table shows the total blood cholesterol level in milligrams per deciliter of blood of 7 patients before eating the cereal and after 1 year of eating the cereal as part of their diets. Use technology to test the mean difference. Assume that the samples are random and dependent and the population is normally distributed. At alpha equal 5%, can you conclude that the new cereal lower total blood cholesterol levels? Okay, guys, since the 2 samples are dependent, before and after you have to subtract the differences. 210 minus 202 is 8. 225, that's a 4. 235 minus 236, this person didn't work. Cholesterol went up. This one went down by 2. Negative, 2 for no, plus 2. 255, 2. 260 minus 257, that's a 3. 230 minus 225, that's a 5. Okay, now you need to test the difference against 0. If this is to work, you would expect the cholesterol to go down. So let's say someone has a 250 before, you would expect it after being on the diet to go, let's say 210. And if you subtract, you get 40, which is greater than 0. So guys, you have to test that the difference is greater than 0. And you select the one that has the difference greater than 0, which is this one. Okay, I'm going to do this on the calculator. So I'm going to go to Stat, Edit. I'm going to enter the data in L1. And let's enter it because it's not much data. So 8, 4, 1, -1, sorry. It looks like the difference is positive, but doesn't mean that it is working. But the difference is not much. Didn't make a lot of difference. It did reduce it, but not much. So probably it's not effective. Let's see. You go to Stat, t-test. It's always a t-test, guys. You see it says T here. And then run the t-test. Data, it's always under data. And here you're testing against 0 in this section. Your data is in L1 and you want to test if the difference is, mean of the difference is greater than 0. And watch. So T is 3 point, how many decimal places? 3 decimal places. So 3.092. And p-value is 0.0107. Okay, conclusion. What was alpha? 5%. This is less than 5%, so you reject HO. And there is enough evidence, sufficient evidence to support the claim new serial totals lowers the blood cholesterol. Okay, testing the difference between two proportions. Determine whether a normal sampling distribution can be used for the following sample statistic. If it can be used, test the claim about the difference between the two population proportion P1, P2 at the level of significance alpha. Assume that the samples are random and independent. Okay, so we need to test the claim that P1 is different from P2. And you guys agree with me that it's going to be this one. P1 equals P2. P1 is different from P2. What are the condition of the test? Well, I might not ask you to verify the conditions of the test, but this is how you verify them here. So you do N1 P1 must be greater than 5. N1 Q1 must be greater than 5. N2 P2 must be greater than 5. And N3 N2 Q2 must be greater than 5. N1, guys, is 74. But what is P1? To find it, you just do 37 divided by 74. And once you get to P1, Q1 will be 1 minus P1, so you can check those conditions. So they are met right here. So I'm not going to waste too much time on this. Calculate, okay. Now let's run the test. So I'm going to take you to the test right away. Two proportion Z test. Don't mix it up with the mean test. These are proportions, P1 and P2. Okay, X1, 37. It's very clear. N1 is 74. X2 is 39. I mean, it's obvious that you should use this test because it asks you to input, the values given there. We need to check that P1 is different from P2. That's the claim. And then hit calculate, guys. So Z is 0.45. Just be the reason why I'm typing in the answer, just to show you that you have to be careful with the rounding. And this one is 0.6539, which is more than alpha. You agree with me? So we fail to reject the null hypothesis. And since the p-value is more than alpha, we fail to reject HO. There is not enough evidence to support the claim. It will be this. All right, so now we're in chapter 9, correlation and regression. Describe the range of values for the correlation coefficient. The range of values of the correlation coefficient are from -1 to 1 inclusive. Your correlation coefficient between two variables can be as low as -1 perfect negative correlation, or as high as 1 perfect positive correlation between X and Y. Which value of R indicate a stronger correlation? Okay, can you guys help me answer this question? Which one is a stronger correlation? The 0.841 or the -0.916? Who can tell me?
A.
Yes, because it's closer to -1. It doesn't matter whether it's negative or positive. It's how close to -1 or how close to +1. That's a stronger one, yes. For each of the scatter plot below, determine whether there is a perfect positive linear correlation, a strong positive, a perfect negative, a strong negative correlation, or no linear correlation. Okay, here guys, this one, no linear. It's actually parabola, so it's not linear at all. Okay. This one is perfect. As you can see, you can fit a line. If you can fit all the points on one line, it's a perfect positive. This one is a strong negative. And this one is a weak one. Is there a weak portion? Strong drag H1, strong positive. So this is gonna go right here. All right. The accompanying table shows the ages and years of 11 children and the number of words in their vocab. Completes parts A through D. Click here, okay, to view the table. And we're gonna show you how to do this one, guys. Okay, here's the table of values. Okay, let's put him on the calculator. Stat, edit. Might have him somewhere. No, I don't. So clear. Okay. Resume recording. So now I'm gonna resume recording. I'm gonna repeat what I did, guys. So after you enter the data in L1 and L2, you go to stat, calc, number 4, enter. And you get R, which is 0. To 3 decimal places, it's 0.97. So we did enter it right here. Describe the type of correlation. We say it's a strong positive. And now we want to interpret. Strong positive means as X increase, Y increase. There you go, right here, B. Now, the next one. Use the table of critical values for the Pearson correlation coefficient, which is R, to make a conclusion about the correlation coefficient. Let alpha equal 0.01. Okay, guys. How many do we have in the sample? 11. Okay, he says use the critical value tables. You click on it. And even to use it, it's self-explanatory. He tells you what to do. The correlation coefficient is significant. The correlation is significant when the absolute value of R is bigger than the value in the table. Okay, what is alpha here? He says, let me just check. Alpha is 0.01. Okay, guys, look what you do. N is 11. Alpha is 0.01, so you get this value right here. Critical value is 0.735. Then your R is 0.97 in absolute value. If it is negative, make it a positive. That's what absolute value means. Okay, look what he says. He says the correlation is significant when R is bigger. Well, R is bigger here, so then the correlation is significant. If this R, let's say, was 0.65, then you say the correlation is not significant. So that's how easy it is to use this table to perform the test. So watch. So you just go, the critical value is 0.735 from the table. There is sufficient evidence to conclude that correlation is significant. And that's it. Next question. Two variables have a positive linear correlation. What do you think the slope is going to be? Positive or negative, guys?
Positive.
Positive. As an independent variable increases, the dependent variable will increase as well. Explain how to predict the y values using the regression line. You just plug in the x value in the equation to find the y value. So substitute, there you go. Is it appropriate to use a regression line to predict the y values for x values that are not within the range? What do you think, guys? Appropriate or not appropriate? When the values of x are not in the range. For example, let me just tell you what I mean by this. Let's say we give you those x values. And we give you the y values as well. If I ask you to find the y when x is 50, that is not appropriate, guys. Why?
Because it needs to be within the values.
Exactly. So it's not appropriate when it is outside of the range. Yeah, that's it right here. You choose A. Because the trend could change. All right, find the equation of the regression line for the given data, then construct a scatter plot for the data and draw the regression line. The pair of variables have a significant correlation. Then use the regression line to predict the y values given 4 x values. So guys, let's try to do this with StatCrunch. Okay, let me show you how to use StatCrunch. So you go, let me see, stat, regression, simple linear. Your x variable is height. Your y variables are stories. Okay, you're gonna like that. And just hit compute. Okay. You want the equation. The equation is this. Y equals 11 point. Let me just mark it. This is the equation, guys. So that's what we need. And you want to see the graph? Just advance, the page, and this is the graph. Let me just clear this. This is the graph, so you can select which one works there. Go back, and the equation will be 11.32 plus 0.0577x. It just times x. So if I write this down, y hat equals 11. I don't remember how many decimal places he asked. Uh, 8x. All right, I'm gonna close this. I don't need it anymore. All right, so you just plug it in here. Oh, 3 decimal places. So that's 11.322 plus 0.058x. If you use your calculator, you have to put x values in L1, y values in L2, and run this. Linear regression AX plus B. Now, if you run linear regression AX plus B and you don't get this window, if you have all the calculator, just press enter. It's gonna do L1 and L2 by default. And you can see this is the graph, guys, that we saw in there. And now predict the value of y for x equals 498. So what you do is just plug in x equals 498. So I'm just gonna do one of them right here. So it will be 11.32 plus 0.058 times, he wants now 498. 40.204, and you just put 0.24. So it seems to me like this is the closest 40. It will be 40, and you select this one. Let's see which one is not meaningful. The smallest value, guys, is 452, and the largest is 764. Is he asking us? Oh, for 345, it's not within the range. So for this one, you choose not meaningful for that one. 736, is it okay? Yeah, it is okay because it's still within the range. All right. Clear. One more question here. The accompanying data are the shoe size and heights in inches of 14 men. Find the equation of regression line, then construct a scatter plot. And then it's exactly the same question, guys. And again, to show you how to do this in StatCrunch, it's just click, open in StatCrunch, and watch how easy it is to do it in StatCrunch. Go to data, regression, simple linear, select the variables, or not shoe size, height, and hit compute. And look, this is the equation. Y equals 53.18 plus 1.702x times x. And you just plug in the values. And for the ones that are outside the range, you just say it's not meaningful. And you select the graph. Which one are not meaningful here? Let's see, what's the table here? So we got from 8.5 to 12.5. So this is okay, 11.5, you can compute it. 8, no, because that's not meaningful outside of the range. 15.5, it's not meaningful, it's outside of the range. 10 is okay. All right, using the scatter plot of the registered nurse salary data shown, what type of correlation, if any, do you think the data have? Explain. Which one would you choose, guys, here? So C is the option here. Find the coefficient of determination, guys. To find it, you can use StatCrunch if you want. Let me show you again. Or you can put them in the calculator. You might appreciate StatCrunch more if you have access to a computer. X variable is issues. Y variable is proceeds. Compute. And look, R square is right here. 0.29. It's very low. So it's 0.29, says 3 decimal places, you do it. So how do you interpret the coefficient of determination? Here's how you interpret it. You change it to a percent. So 29% of the variation in the Y variables can be explained by the variation in the X variables. So let's see which one reflects on that. The coefficient of 0 is a fraction of the variation in Y that can be explained by the variation in X. That should be this one. right here. Find the standard error of estimates, guys. You already have it. We did it in StatCrunch right here. Let me show you. Okay, I'll go back and do it. Open in StatCrunch. I'll show it to you. Regression, simple linear. I have to select the X variable one more time. Okay, where is S? Standard error of the estimate. Here you go. It's right here. If you don't use StatCrunch and you are asked to do the standard error of the estimate, here's what you do in the calculator. So you go stat edit, you enter the X values in L1 and the Y values in N2, and then you go to stat tests and linear regression t-test, guys. Let's say this is L1, you make it L1, L2, and then you can choose anything here. If I'm asking you to test the hypothesis for positive, negative, you can choose that one, but it doesn't matter. And then you hit calculate. And once you hit calculate, it will display S. It's right here. Well, it's different from what you've seen because that's two different data sets. This is S. This is T, and this is the p-value. All right. And the standard error of estimate is an estimate of the Y values, not the X values. So if you are to choose an answer here, it will be estimate of the proceeds because the proceeds are the Y values. Okay, find the expected frequency. We're doing now chapter 10. EI for the given value of N and PI. Well, it's 170 times 0.27. The expected value is the probability times the sample size. So it will be 0.27 times 170, 45.9. Next. Okay. Probably have time to do this one. Okay, let's do this. A research firm claims that the distribution of the days of the week that people are most likely to order food for delivery is different from the distribution shown in the pie chart. You randomly select 486 people and record which day of the week each most likely to order food for delivery. The table to the right shows the results. These are the observed values. Test the claim. Okay, the distribution of the days people order food for delivery is as claimed, is as shown in the pie chart, different from the expected distribution. You use the word uniform when all the distribution, the percents are exactly the same, but here it's just, he gives us different distributions. Okay. They claim that the distribution is different from what's in the pie chart. So the claim is in HA, guys. And how do you calculate the test statistics? You need the observed values and you need the expected values. These are the observed values, the frequency, you put them in L1. The expected values are gonna go to L2, and let me show you how to find the expected values. So here's how you do it. You go to Stat, Edit, L1, clear, L2, I'm gonna clear this one, and I'm gonna do this on the calculator. So let's do it together. So 47, 14, you'll help me with the next one, 26, 40, 46, 162, 151. Okay, let's go now to list 2. Now, for Sunday, to find the expected value, you take the 80% and multiply by the total, which is 486. So I'm gonna do it right here on the spot. 0.08 times what was it? 486. For the next one, for Monday, guys, as you see, it's a 3%. So 0.03 times 486. You can do them separately and you can do them right on the calculator. For Tuesday, I have 7%, as you can see. So 0.07 times 486. For Wednesday, we have 12%, 0.212 times the total, always the total of all, 486. For Thursday, picks up 10%, 0.10 times 486. And two more, guys, 35%, 0.35 times 486. And the last one is 25%, 0.25 times 486. Once you do that, you're almost there. And now you go to stat, tests, scroll up. It is called the chi-square goodness of fit test. When you have more than two percentages, it's a goodness of fit test. Okay, observed values are in L1, expected values are in L2. Degrees of freedom is number of categories minus 1. I got 1, 2, 3, 4, 5, 6, 7. So minus 1 will be 6. You have to adjust this one and hit calculate. Okay, your test statistic is 17.05. How many decimals? It says 3 decimal places. So 0.52. And the p-value, guys, is 0.009. Okay, I'm done here. Decide whether to reject or fail to reject. Well, you reject HO because it's less than alpha, the p-value. And the claim is in HA. At the 1%, there is enough evidence to conclude that distribution has changed. Differs from the expected distribution. Recording. All right, a researcher claims that the number of homicides crime by season is uniformly distributed. To test this claim, you randomly select 1,189 homicides from a recent year, record the season when each happened. Okay, here, the distribution of the number of homicide by reason is uniform. The distribution is not uniform. Okay, test the claim. The claim is the number of homicide crimes is uniform. That means it is an HO. Okay, calculate the test statistic, guys. Let me show you how to do that. So we're going to go to stat, edit, L1. I'm going to clear it. And we'll show you L2 is going to be a lot easier than the previous question. So L1, I have 300. I got 310. I got 299. I got 280. For L2, uniform means they are the same. These are the expected values. So look what you do, guys. You take this total here and divide it by the number of categories. So you have 1,189 just divided by 4. If you had 5 categories, you divide it by 5. So 1,189 divided by 4. So 297.25, everybody, 297.25, 297.25. That's it. And let's run the test. Stat, tests, scroll up, it's goodness of fit test, enter. Degrees of freedom is 3 here. Because 4 minus 1, guys, is 3. Calculate. Okay, chi-square is 1.584. P-value, oh, it's a huge, 0.66. How many decimals? 3 decimal places, 3. Well, you guys agree with me, it's bigger than alpha, so you fail to reject HO. There is not enough evidence to reject the claim that the distribution is uniformly distributed. All right, next. The table to the right contains the observed values and expected values in parentheses for two categorical variables. When you have something like that, this is a section on the independence test, where variable X has 3 categories and variable Y has 2 categories. Compute the value of the test statistics. So here's how we're gonna do this, guys. To do the value of the test statistics, you have to put the observed values in a table. And I'm gonna show you how to do that in a matrix, which we did before. So look what you do. You press second and matrix. Then you go to edit. Oops, sorry. Enter. Okay, I have a 2 rows and 3 columns. 2 and 3. Enter. And then you enter the observed values, not the expected values that are in parentheses, the observed values. 33, 43, 45, 19, 21, 14. And quit. That's it. Second and quit. And now go to stat, tests, scroll up. It is chi-square test. And put observed values in a matrix. Okay, so let's hit enter. Okay, the expected value, we already have him, but we're gonna get him in matrix B, but we don't need him here. Calculate, okay. So the test statistic is 2.307. Test the hypothesis that X and Y are independent. Remember, in this section, the null hypothesis is the variables are independent. The alternative, the variables are dependent. So let's see which one is gonna be. There you go. Independent, dependent. What's the p-value? The p-value was 0.3156, which is actually greater than 0.10. He's giving you choices here. This is the one that I can pick here, which we're gonna fail to reject the null hypothesis. Do not reject the null hypothesis. And he says, test the hypotheses that are independent. So that means the claim, guys, is in what? In the null hypothesis. So you fail to reject the null hypothesis. There is not enough evidence to reject the claim that the variables are independent. Let's find this one. So it's between this and that. No, do not reject HO. There is sufficient. No, we don't say there is sufficient evidence what you don't reject. So actually, guys, you don't even need to rate the rest. This one, it's going to be D. All right. Clear all drawing. The table available below shows the heights in pounds for a sample of vacuum cleaners. The heights are classified according to vacuum cleaner type. At alpha equal 1%, can you conclude that at least one mean is different from the others? So we got the data, guys. We're gonna put them in lists.
Mr. Bazzi, do you think you can go through this one on StatCrunch? Because I could not figure out how to do this one.
Let me just do it on the calculator, and then I'll show you how to do StatCrunch later,
Okay.
separately.
Sounds good. Thank you.
Okay, so we got 23, 22, 25, 26, 24, 20. And let's go to the second list, guys. Clear. 17, 18. This is the last section, guys, 10.4, 20. I told you there will be no question from 10.3. We just did the homework for that, so there will be no questions from 10.3. So I'm not testing this section, but very likely you'll see questions probably from this section. And then go to L3, clear it. Don't delete it, clear it, and press enter. I got 23, 21. So the challenge here is just to enter the data, guys. 24, 26, 25, 20. And if I were you, I will double check on my data set just to make sure that I enter stuff properly, because there's no way for me to know what you entered there. And we're gonna go to stat, tests. It's the last test, ANOVA. And you enter, guys, second and L1, comma, second and 2, comma, second and 3, close it, and enter. I got everything I need. Now I can go back to this. Okay. As I told you, the null and the alternative don't change. Mu1 equals mu2 equals mu3. At least one mean is different. Where do you find this? You find it in C. What is the test statistic? We use an F distribution. It's 13.85. What's the p-value? It's okay. You see the E minus 4, guys. I'm glad that this happened, so you see what to do here. Don't put 3.91. That will be wrong. You move the decimal place 4 digits to the left, so it's going to be 0.00039. How many decimals? He says 3, so it's going to be 0.000. That's the answer. Reject HO, and where did we say the claim here? Can you conclude that at least one mean is different from the others? So guys, the claim is here in the alternative hypothesis. So we reject HO, there is enough evidence to support the claim. That's what I'm trying to say. So it's between A and C. There is not, yeah, you can't use this. I wouldn't even, that's it. There is enough evidence to conclude that at least one mean is different from the others. Okay, here's another one. The table available below shows the cost per mile in cents for a sample of automobiles at alpha equals 0.01. Can you conclude that at least one mean cost is different from the others? Okay, guys, I'm not gonna do this using the calculator. So you just put the data in L1, L2, L3, L4, and L5. And your null hypothesis will be this. He didn't use 1, 2, 3, 4, 5. That's fine. He uses the labels. So let me just put some directions for you. So put data in L1, L2, L3, L4, L5, and then run ANOVA L1, L2, L3, L4, L5, and then you get F and you get the p-value. Here you go. He says F and the p-value, and then choose your conclusion. Now, what is the claim? Let's see. Can you conclude that at least one mean is different? So the claim, guys, is right here. If the p-value is less than alpha, you will conclude, you will reject HO and support the claim. If the p-value is more than alpha, you say there is not enough evidence to conclude that all means are equal. All right, so I'm gonna skip this. All right. Let me clear this. Listed below are amounts of court income and salaries paid by the town justices. The amounts are in thousands of dollars. Construct a scatter plot, find the value of R, p-values, and is there sufficient evidence to conclude that there is linear correlation between court incomes and justice salaries? So I'm gonna do this one, but I'm gonna do it in StatCrunch. Okay. There is a linear correlation. Okay, we're gonna do it in StatCrunch, open in StatCrunch. That's gonna be quick. And stat, regression, simple linear, X variable, salary. Okay, here. When you test the correlation coefficient, it is a slope. It's testing, just the slope. And he says, can you check if there is correlation? He didn't say positive, he didn't say negative, so we choose different from 0. If you were doing a linear regression t-test, guys, right here, you will choose different from 0 here. You put the data in L1, L2, and different from 0. So just hit compute. All right. And look, guys, you got everything you need. You get R, you get R squared, you get the estimate, you get the slope. Just look at the slope. Don't look at the intercept. You look at the test statistic right here, the p-value, so everything we need. So let's do this one and get some of the values here. Okay, so we're doing, this is the null and the alternative hypothesis. To check which one is the correct graph, you just go to the second one and this is it. So which one do you think it will resample that? Like probably this one. Linear correlation coefficient R, guys, I'll bring it back up. Go back. R is 0.877. Test the statistic T. Let's go back, bring it back. The slope, 4.829. You should get the same thing if you use your calculator, but it's faster. And this one is 0.0019, I believe. Because the p-value is less than alpha, there is sufficient evidence to support the claim that there is linear correlation between the two. So this is the question. And let's see what else we have here. All right. This is another question, guys, on F-test. But if you hang in there, once I stop the video, I'll show you how to use a StatCrunch for this one. You would have to enter L1, L2, L3, and L4 in there. It's a lot of work to do this. So, I'll just have to select an answer before I can move in. And 61, we're almost done, guys. The length of a 10-year-old female's upper arm is approximately normal distributed with a mean of 30.7 standard deviation. Complete parts, draw a normal curve. So you need the 30.7 to show in the center, and the standard deviation 2.1. You need 3 standard deviation of 2.1 here. So 2.1, yeah, I think that one would work right here. So that would be this. Shade the region that present a proportion of 10-year-old females whose upper arm length is less than 29. less than 29, guys. So this is it. This is the 29 right here. So I would say probably this, as you can see. This is 29. It will be that. Suppose the area under the normal curve to the left of x equals 30 centimeters, 0.3694. Provide two interpretations of the results. The proportion of 10-year-old female with upper arm length less than, so at most 30 means less than. To the left of 30 means less than 30 is 0. Another interpretation, guys, the probability the randomly selected 10-year-old has an upper arm length of less than, or not at least, at most, sorry, is 0.384. So this is back to chapter 5 review. The mean gas mileage of a hybrid car is 56. I'll tell you why I put this question in there, guys, in a second. That's the mean. Suppose that gas mileage approximately normally distributes with a standard deviation of 3.3. What proportion of hybrid gets over 62 miles per gallon? Proportion, guys, means the probability. So here he wants the probability of X more than 62, which is you have to use normal CDF. 62 is a lower bound, upper bound is a million, mean is 56, and standard deviation is 3.3. So the reason why I put this question, if you see the word proportion, it's the same thing as asking you to do probabilities. So if you just go to second and distribute normal CDF, and you put 62, and then you put a million. Oops, what happened? Second variable, normal CDF. So 62 million, mean is 56, and standard deviation is 3.3. And the answer is 0. You just put the answer here, 0.0345. Proportion of hybrids gets 51 miles per gallon or less means the probability of X less than 51. So for this one, guys, you just do normal CDF, negative a million, 51, 56, and 3.3. Proportion of adults between 59 and 61, you just, lower bound is 59 and upper bound is 61. Less than 46 will be negative a million, 46, then mean 56, 3.3. So it's the same thing as you did before, but he says he uses the word proportion in here. And let's see what else. Oh, here you see pop up showing you what the formula to use. This is to use what size sample should be obtained if you wish to estimate to be 0.05 with, so the margin of error E here is 0.05. We want to estimate the proportion. Here's the formula, and I will provide you with the formula, guys. ZC over E squared. If no preliminary estimate is given, okay, she used previously an estimate of 0.56. So for A, it will be this, 0.56. Q hat will be 1 minus 0.56. ZC for 90%, 99%, guys, we did it earlier. It's 2.75 divided by 0.05 squared. And make sure to round up your answer. For B, no preliminary estimate. So you use N equals 0.5 times 0.5 times 2.575 divided by 0.05 squared. And again, you must round your answer up. So if you get like 200.05, you make it 201. Okay. Use formula. Determine whether the samples are dependent or independent. We're almost there, guys. A data set includes the list of prices and selling price for each of 80 randomly selected homes. Do you think the samples are the list price and selling price for each of 80 randomly selected homes? What do you think, dependent or independent? Well, it says it's a listed price and the selling price of the same home, so they are dependents because the selling price depends on what's listed for. Okay, so samples are, there is a natural pairing between the two. And last question. The following data represent the pH of rain of random sample of 12 rain dates. A normal probability plot suggests the data could come from a normal population. A box plot indicates there are no outliers. Okay, determine a point estimate for the population mean. A point estimate for the population mean is the sample mean, guys, and you can do it in StatCrunch. Watch. There's StatCrunch. To find the sample mean, just go to summary statistics, columns, variable 1, compute, and here's X bar 5.036. So you just put it in there. Construct a 95% confidence interval. Okay, and 99%. I'm gonna do it on StatCrunch, guys. So we're gonna go back to StatCrunch and show you how to do this. Go to Stat, T stats. When you have data set, it's a T, one sample with data. If you are to use a calculator, you put in data in L1 and run a T interval. But with this one, watch, guys. Variable. Okay, I'm not doing hypothesis test. I'm doing confidence interval. He wants 95%. Watch. Compute. Here's the interval. 4.77, 5.31, if it is 2 decimal places. There is a 95%. Okay, 4.77. I don't remember what was the other one. And 5.31. Now to find a 99% confidence interval, look, guys, what you do. So close this, go to Stat, T stats, one sample with data, variable 1, and change the 95 to 99. Compute. There's the interval, 4.655, 5.41. So you can get it off the interval. What happens to the interval when the confidence level is changed? If we increase the confidence level, the interval will widen. And that's what you need to select. All right. So that concludes the review